Hi guys, in this video I'm going to teach you how to understand the unit circle, how to memorize it, and how to understand it, how to actually use it. So what is the unit circle? The unit circle is just a circle with a radius of 1 centered at the origin. So here's the origin and here's the radius of 1. Okay? So every point on the circle represents an angle, and that point has coordinates, cosine theta and sine theta. What this means is that it's very simple. X equals cosine and y equals sine. So instead of memorizing random values, you're really learning coordinates. So let's start with the most important angles you gotta know. We have 0, we have pi over 6, pi over 4, and pi over 3, and also as well pi over 2. So in degrees, this is just 0 degrees, 30 degrees, 45 degrees, and 60. Oh, and 90 degrees. So you gotta remember this. They are important. But you will be asking, how do you convert these power sets to 30? There's a really good form to do this, and it's really simple. You have to remember that when you want to convert pi over something to an angle, you use this. Like, I want to convert pi over 6 to degrees, right? So I just multiply by 180. We just multiply by 180 over pi. And that should give us 30 degrees. So that's just 30. Because these two cancel, and it's just 180 over 6. And you can do the same for the other ones. For pi over 4, you can do the same thing. Pi over 4 times 180 over pi. You cancel this out. And how much is 180 divided by 4? Very simple. That's 45. So whenever you want to do pi 2 degrees, you just have to multiply by 180 over pi. And what if you have degrees? If you have degrees, it's the other way around. You have 30, so you are going to multiply this by pi over 180. And this is equal to 30 pi over 180. And you just have to simplify this, which will be 1 over 6 pi over 6, and that's just pi over 6. So you just have to remember this. This is the actual rule. When you want to convert to pi's, you just have to multiply by pi over 180. It's a normal conversion factor. There's sometimes asked in tests or in quizzes where you have to actually transform. I would recommend to memorize this thing and start practicing it. But the real thing we have to know is the unit circle. So let's get to it. Okay. So here's where most students struggle, and I can relate to this because I struggled with this as well on my first semester of precalculus. So it's going to be very simple and straightforward. You just have to know these three angles. You have pi over 6, pi over 4, and pi over 3. What you have to remember is that this one represents a 30, this one a 60, and this one a 45. Why? Because if you go like this, makes an angle of 45. If you go like this, makes an angle of 30. If you go like this, it's an angle of 60. And what's an angle of 90 degrees? It's over here. In 90 degrees, in radians, is just pi over 2. So now, how do you really memorize this whole thing? You will be asking. So to memorize this thing, all the things you have to do is just keep adding the pi over 6 and the pi over 4s. So what I recommend doing is just adding the pi over 6 over and over to get all the other pi over 3s and pi over 6. The pi over 4 has its own thing, but I'll get to that later. So first you have the pi over 6, right? So pi over 6 plus pi over 6 plus pi over 6 is just 2 pi over 6. 2 pi over 6 is just pi over 3. Because you divide both sides, top and bottom, by 2. And that gives you pi over 3. Then you add the 2 pi over 6 plus another pi over 6. And that's 3 pi over 6. That's equal to pi over 2. Okay. Now, for the other ones, you'll do the same thing. Keep adding these angles until you get all of them. It's really easy to memorize them if you do it this way. So now that you have, do it like this way. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. How much is 4 pi over 6? We reduce everything because we want the smallest thing. So that just be 2 pi over 3. Okay? And then we ignore the pi over 4 angle there for a moment. And then we add the 4 pi over 6 plus another pi over 6, and that's just 5 pi over 6. And then we add another pi over 6, and that's just 6 pi over 6, which will be pi. Pi equals 180 degrees. And then the 6 pi over 6 plus another pi over 6 is just 7 pi over 6. Okay? Then you have this other angle. This one, 7 pi over 6 plus 8 pi over 6. Plus pi over 6 is 8 pi over 6. What is this equal? This is 4 pi over 3. So you start to see all the angles here start to make sense, because the 3's line up with the other 3's that are on the quadrant 1, 2, and 3. You can also remember that quadrant 1, both x and y coordinates are positive. Quadrant 2 are negative and positive. Quadrant 3 are negative and negative. And quadrant 4 are positive and negative. But that's important for another part of this unit circle, which I'll get to that later. So you have now 8 pi over 6, and that plus another pi over 6 is just 9 pi over 6, and that's just about 3 pi over 2. Now what you want to do is just do this 2 more times, and you'll be actually really done with all the 3's and 6's fractions of pi's, and then you can get to the 4's. So do the addition, and you get the other 2 angles. Okay, so 9 pi over 6 plus pi over 6 is just 10 pi over 6, which is 5 pi over 3. Okay, hold on. Okay. And then you have 11 pi over 6. And then 12 pi over 6. So 12 pi over 6 is just 2 pi. And that's a full cycle of a circle. 2 pi equals a full cycle of a circle. 2 pi equals a full cycle of a circle. So now you have to remember the other force, but you just have to know this. You do the same thing for the pi over 4s. So pi over 4 plus pi over 4 is 2 pi over 4. That gives you pi over 2. And you do the counting. Pi over 4, 2 pi over 4. 3 pi over 4. 4 pi over 4 is just pi. Then 5 pi over 4, then 6 pi over 4, and then 7 pi over 4. And you already write down. Okay, so now we'll get to the important thing, that is evaluating angles. So let's say they ask you, what's sine 5 pi over 6? Okay? So you have to remember your benchmark angles. This 6 represents that you're going to have a 30-degree angle reference. Reference angle. So what that means is that you're going to use a triangle that is going to be like this. Not necessarily in this direction, but will look like this. And we'll have the y value with the 1, okay? So if you recall, where is 5 pi over 6? Well, that's your second quadrant, right? So what you do, this graph, and do the triangle here. Here lies that angle, and here is the 30. Now you put the 1 here, and remember the signs, okay? Some people forget the signs, so this is a negative and a positive. So you'll go negative square root of 3. Why negative square root of 3? Because of the special triangles. The 30, 60, 90, and the 45, 45 are the most important triangles you have to know for trigonometry and precalculus. So if they ask you for the sine, they are just asking you for y over r, right? So y over r is just taking this one over the radius, which is the hypotenuse, right? So the hypotenuse is 2. So this answer is just going to be 1 over 2. That's simple. Now, let's say you want to evaluate cosine of 11 pi over 6. Well, you draw this, which is a graph, and you do the triangle. You gotta recall your angles to do the triangles. So the 6 represents a 30 reference angle with a negative 1 and a square root of 3 as you read, and a 2 here. So what is cosine 11 pi over 6? Cosine is h over r. So h is a square root of 3 over 2. So this is just square root of 3 over 2. Okay? So you'll get the idea of how this is. You have to remember your reference angles. So here's a rule that can help you out if you struggle with this. When you see that one of the angles have a 3, this means a 60 reference angle. They have a 4, 45 degree angle. They have a 6, a 30 reference angle. But you can also be asked about the quadrantal angles. The quadrantal angles do not have reference angles. The quadrantal angles are 0, pi over 2, pi, and 3 pi over 2. And since they don't have reference angles, what we use for the evaluation of these angles is just coordinates. You have to remember 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So that's just it. What's sine of 3 pi over 2? You have to remember, sine represents y. So y at 3 pi over 2 is negative 1. Why is this? you just have to draw this. If you want a visual to help you out, you draw this. And here is 3 pi over 2. And here's the 0 and the negative 1. You're looking for y. And you say, wow, but how do I use the radius if I don't have radius? You have the radius. The radius is 1. So this is just negative 1 over 1, which is just negative 1. So this equals negative 1. Now, what if you are asked about the tangent of an angle? Tangent just means y over x. Let's say like tangent of 3 pi over 4. You draw a triangle on the direction of the angle. Draw the 45 because it has a 4. Okay? Just draw a 1 and a negative 1 and a square of 2 over here. So tangent is just y over x. So tangent 3 pi over 4 equals negative 1. Because 1 over negative 1 is just negative 1. Okay? And now, what if you do tangent of pi? So tangent is y over x. And here, x is negative 1 and 0 is y. So if you divide 0 by negative 1, what you get is a 0. So any number, 0 divided by any number is just 0. Okay? So for this answer, you will just put the 0. It's very important that you remember this, because sometimes you can confuse and write another type of thing. Okay? Now let's see for another one. Let's say you want to evaluate tangent of 3 pi over 2. You can pause the video and do it by yourself. So what you do is you draw a point here on the quadrantal angle of 3 pi over 2, and you know this is 0, negative 1, right? And tangent is y over x, so this is negative 1 over 0. But wait, this is not something that we can work. Any number divided by 0 is just undefined or does not exist. So if you get an answer like that, what you really have to do is just D and E or undefined. This does not exist. Any number divided by 0. If you write that to a calculator, will give you an error, or will give you a syntax error, or whatever it is. But that is not something that you're expected to get a number. So now moving on. Something that is really helpful is to also memorize the coordinates of the unit circle. So for the last thing on this video, we are going to understand the coordinates. You probably see this as complicated because you don't know how to memorize it. But once you memorize this thing, you don't have to be drawing triangles all the time. However, you can still do it. That's the old-fashioned way. But it is helpful to have this memorized. It's always helpful. So what this just really means is telling you, ask yourself, what's cosine at pi over 3? If you recall, this has square root of 3, 1, and 2. Cosine is 1 over 2. So I start with 1 over 2. The cosine of pi over 4 is really super simple. You just have to remember it's the square root of 2 over 2. Why, you will say? Okay, so visual, you have a 45, right? And the square root of 2. So what's cosine at pi over 4? Well, 1 over the square root of 2, right? No. You don't want radicals under your fraction. You just multiply by square root of 2 to cancel out the radical, and it becomes square root of 2 over 2. That's the same for sine, because sine and cosine are the same at the first quadrantal. I mean the same on the signs. Just remember, both are positive. And tangent is also positive on the first quadrant. So what's cosine at pi over 6? Now notice this pattern. It's 1 over 2, square root of 2 over 2. What will be cosine at pi over 6? It's the square root of 3 over 2. Why? Because if you draw the triangle for pi over 6, it's just 30 with a 1 here, square root of 3 here, and a 2 there. And cosine is just h over r. R is your hypotenuse, and your hypotenuse is 2. So square root of 3 over 2 is just square root of 3 over 2. Okay? Now for the sines, it's going to be the opposite way. Just remember that sine for pi over 4 is also square root of 2 over 2. And sine for pi over 6 is 1 over 2. The sine for pi over 3 is square root of 3 over 2. Coordinate for pi over 2 is 0, 1. That's just a quadrantal angle. So you're going to understand that you're going to have the square root of 3 over 2, square root of 2 over 2, 1 over 2. All of these coordinates are going to be repeating along the unit circle, just changing the signs. Once you know these coordinates, you can write all the other coordinates on the unit circle. So we use the unit circle coordinates to evaluate trig functions, like getting the exact values of sine, cosine, and tangent without a calculator, finding missing sides in triangles, especially in right triangles using trig ratios. We also use these coordinates to graph sine and cosine functions, since the unit circle explains why waves go up and down. And we can also use this to solve trig equations, like finding all angles where sine theta equals 1 over 2. And we can understand radians, not just degrees, since the unit circle is built around radians. And furthermore, you can also find tangent, secant, cosecant, cotangent using relationships. But I'll get to that on another video. So, how do we get to the other coordinates? Well, here is negative and positive. So the 1 over 2 is going to be a negative 1 over 2. And the square root of 3 will be just a square root of 3 over 2. Okay? Just remember that. Now, for the pi over 4, this is a negative square root of 2 over 2, comma, square root of 2 over 2. Why? Because you moved to the left. Moving to the left means going negative. And for 5 pi over 6, this is negative square root of 3 over 2, comma, 1 over 2. You see the pattern? Now obviously here you have your negative 1, 0, and that's also the same thing as the other ones. The x values are negative and the y values are positive. So now from here to there, what's the thing for 7 pi over 6? The coordinates are cosine and sine. What's cosine at that coordinate? Negative square root of 3 over 2. Why? If you don't remember, you can always draw these triangles to give a visual of what you're trying to accomplish. So, you know it's a 30, right? This is a negative 1, this is a negative square root 3, and this is a 2. What is x? Or what is cosine? That's negative square root 3 over 2. So you just draw, you just write that. You just write that info over here. And the y will be negative as well. You see, all of them are the same. They are just changing their signs, becoming positive or negative as they enter the other quadrants. So for this quadrant, both x and y are negative. For quadrant 4. And it will be as that easy. You will go drawing all the other angles on and on. So knowing this pattern, well, what will go next after the negative square root of 2 and comma negative 1 over 2? Negative square root of 2 over 2, comma negative square root of 2 over 2. And that's just right. Okay? And then for the last one, you will get the negative 1 over 2, comma negative square root of 3 over 2. And then you do the same thing here. You can see that you're going to get a positive 1 over 2, but a negative square root of 3 over 2. Why is this? Because here is positive and y is negative. So all your y coordinates are negative. So today you learned that the unit circle is not just something to memorize, it's something to understand. We saw that every point on the circle represents cosine theta, sine theta, which lets you find trig values instantly. You learned the key angles, the pattern with square roots, and how to use quadrants to get the correct signs, so you don't have to memorize the entire circle. We also use the unit circle to evaluate trig functions and understand why it's so important for precalculus and beyond. If you can master this, everything in trig becomes way easier. If this helped you, make sure to like and subscribe. I'll keep making math simple and straight to the point.